Hi, my name is CJ and I'm with Post-Quantum and Nomidio. In this talk, I'm going to share with you our work in migrating our Nomidio Identity Cloud to Post-Quantum cryptography. This is the agenda of my presentations, so I'm going to start by giving you a quick overview of the threat posed by quantum computers, what the industry is doing in tackling this impending threat, and what are the challenges that we collectively face in tackling this issue. I'm also going to give you a quick overview of our Nomidio Identity Cloud and why we think it is crucial for us to migrate to post-quantum. We'll then move on to talk about our post-quantum migration approach on Nomidio, stressing the importance of backward compatibility and crypto agility. Quantum technologies is an emerging field in physics and engineering that exploit quantum properties. These technologies has tremendous potential, but at the same time, it is also very disruptive, in particular to our digital security. We rely on cryptography to protect our digital security. In general, we can put the crypto into two camps. One of the camps requires us to share a common key, and this crypto is commonly known as symmetric cryptography. This includes things like AES, Tjhai, and Salsa. In order to break this crypto, we need to be able to know the common key. So one way to do that, obviously, is to brute force search for this common key. Our current computer are not very good in doing this task, so we are secure. Quantum computer, on the other hand, is pretty good at this thing, and it's pretty good using Grover algorithm to do unstructured search. And by using Grover's, one predict that the security level offered by the likes of AES will be reduced by a factor of 2. Luckily, this is still not a threat to our security. By simply increasing the key size, we will be all right when we go to post-quantum. There is another type of crypto, the RSA and elliptic curve. They have completely different story. This crypto system underpins the security that we have on the internet. Now, it is commonly used to share the common keys that are needed by the likes of AES. Both RSA and elliptic curve, unfortunately, do not share the same luck as AES. It will be broken by a quantum computer, and one cannot just increase the key size. So if we don't do anything about it, we will not have secure internet. So what does that mean? Does that mean that we are heading towards doomsday? Luckily, it's not. We are in good hands. There are ongoing and active activities in creating new standard for cryptographies that is resistance against quantum computer attack. The work spearheaded by NIST is very close in coming up with the first set of standard. We at PostQuantum are involved in this activity. We are a member of the Classic Mickley submission team, one of the submissions that is in the finalists in the NIST PQC standardizations. While NIST is busy coming up with the standardized crypto primitive that is post-quantum, there is also ongoing effort in IETF, a body that develops our internet protocol standards. Now, we also are active in this space. We are working with IETF to come up with a new protocol that will make sure our VPN is secure in the world of post-quantum. There are also other bodies like ETSI, ITU, ISO, X9, and there are some that are country-specific that are looking at this space. So what are the challenges for us? Well, crypto has been such a fundamental technique, and we have embedded that into almost everything that we do, either in software or hardware. So as such, if we are trying to replace the likes of RSA and elliptic curve, this is going to be complex and time-consuming. We have learned from our experience that even a simple crypto migration would take a pretty long time. With post-quantum, one's got to remember that this has not been attempted before. As such, its scope and scale are unprecedented. One of the first things that one needs to do in order to do crypto migration is to have a catalog of where crypto is used, what is the purpose of it, and then assess the risk. Now, with crypto being so ubiquitous, it is not surprising that discovering and documenting where it is used may take a few years to complete. Poor documentations and legacy system may add further complication to this process. As such, we believe that for organizations that need to keep data secure for a long time, it is a good idea to plan early on this. There's also added time pressure caused by collect and decrypt later attack. We know that there are some APTs and nation state are collecting internet data now so that they can be decrypted later once they have access to sufficient computing power, like a quantum computer. So if you are sending data that need to be kept confidential for a long time, such as trade secret, intellectual properties, state secrets, and so on, you will need to take this risk into account. Similarly, if you are developing a new application, you should also take this into account the ability to migrate to post-quantum, or even better, be PQ ready. This is exactly what we've done a few years ago. But in 2014, we wanted to show that we could have a practical application with post-quantum cryptography. So we created a secure messaging app where the messages were protected using quantum-safe crypto. In fact, at that time, we used McLeese crypto systems. We launched it in Apple and Google Play Store, but unfortunately, we had to take it down in 2015 because we were told that it was potentially used for bad purposes. Okay, so now let's switch gear to Nomidio. The purpose of this talk is that we want to share with you our work in migrating Nomidio to post-quantum cryptography. But before we get into that, let me say a few words on what Nomidio is about. Nomidio is a division within post-quantum that offers cloud-based multi-biometric and multi-factor digital identity service. It is delivered truly as a service with zero or minimal integrations, and from customer perspective, there's no need to download an app. Everything is browser-based. Once a user is onboarded into the system, they can use their Nomidio identity to interact with call centers, chatbot, and even use that same identity to do single sign-on to their corporate system without the need of using password at all. At the center of our service is our Nomidio Identity Cloud. And Nomidio is available in two forms, namely Nomidio IDaaS, which is used for call center and chatbot, or Nomidio OpenID, which is mainly used for single sign-on. As I mentioned earlier, one of the first steps in crypto migration is to have a catalog where cryptos are used. Now, in order to help us with this, we have dissected our Nomidio system into layers and components, and at a very high level, this is what it looks like. At the bottom layer, the connectivity layer, Nomidio can be accessed via TLS, or in some cases, VPN connection for enterprises. As with many modern applications, we are relying on JSON Web Token for our authentication layer. And on top of this layer, we have our microservice component, and some of which implement application-specific crypto. So let's start by looking at the migration at the bottom layer, the connectivity layer. This is a simplified diagram of our Nomidio infrastructure. As with many modern cloud-native applications, it is orchestrated and deployed using Kubernetes. We have a layer 4 load balancer in front of our cluster, and sitting behind that load balancers is our ingress controller that we use to terminate any TLS connections. There's also a VPN gateway for enterprises that needs to be connected over VPN to access Nomidio. So these two are the main entry points to Nomidio. A user will access Nomidio using a TLS connections. An enterprise have the option of using either a VPN, or if they don't need VPN, they can also access Nomidio using TLS. As we know, both TLS and VPN still relies on non-quantum safe crypto to establish a tunnel between communicating parties. Obviously, if the data that are being transmitted are not that sensitive, perhaps we can live with the risk now. But for us, this link may carry sensitive data such as biometrics and PI data, and as such, we believe that we need to keep it secure for a long time and also protect it against collect and decrypt later attack. So we therefore need to upgrade our TLS terminator as well as the VPN gateway so that we can have quantum safe connectivity on these 2 points. We started by upgrading the VPN gateway. So in particular, the IPsec IV2 VPN, which is one of the most commonly used VPN that we have. It is sort of built in almost every operating system. It comes natively, and you can, if you're interested in our work on this, you can find that in IETF working group. And we are quite hopeful in this that it will be turned into standard very soon. Following that, we also extended TLS 1.3 so that we can have post-quantum key exchange with TLS 1.3. And once we've got that, we deploy it to our TLS terminator as well as to the Kubernetes control plane. Now, for both extension work that we have done, we obtain quantum safe connectivity by performing hybrid key exchange. Now, what does hybrid mean? Well, hybrid essentially means that we combine our current crypto, which is not quantum safe, with a crypto that is quantum safe. The combination is done in such a way such that for an attacker to be successful, they need to break both of them. But you may then ask, why do we need to use our current crypto? We know that it will not be secure against quantum computer. Well, the thing about crypto is that it is about trust. Simply replacing our current crypto, which we have used for a long time, that is well trusted, with relatively new crypto that is post-quantum, is relatively risky. We believe that there is still no quantum computer that can break our current crypto currently. So it makes absolute sense to keep on using our current crypto. But in order to protect our data from this collect and decrypt later attack, we should layer in the new crypto that is quantum safe. So we want to use them together. Another reason is potentially due to certification or compliance constraint. You may have a service or product where it is FIPS certified, for example. Now, if you replace either RSA or elliptic curve with this new crypto, then you will lose your FIPS certification. On the other hand, if you use the current crypto that is FIPS certified, combine it with a new crypto, the post-quantum one, provided that you combine them properly, you can maintain your FIPS certification. Hybridization also allows us to achieve backward compatibility, which is crucial for post-quantum migration. I'll come back to this point later. With new crypto, there is always risk that it is not as secure as one hopes it would be. So in order to hedge against this risk, we have built in our both TLS and VPN extension the ability to exchange more than one post-quantum crypto. That is, instead of using one elliptic curve and one of the PQ algorithm, you can use our extension to combine elliptic curve with one or more of the PQ algorithms. We believe this multi-key features is important for transition to post-quantum cryptography. Similarly, crypto agility is equally important. We want to be able to replace crypto easily without affecting the higher layer applications. Okay, now I'm going to show you some examples of how hybridization achieves backward compatibility, why it is important for post-quantum migration. Here you have Alice. Alice wants to talk to Dotbird via TLS. So Alice sent her data, the standard TLS data that we know, standardized version of that to Dotbird. Now, Alice being Alice, she's always up to speed with things. And in fact, in this case, Alice is PQ ready. So in addition to sending her standard TLS data, she also sent the extended data that is post-quantum. But Alice doesn't know whether or not Dotbird understands this thing, but she sent it anyway. So on receiving that, Dotbird can see that actually Alice is PQ ready. So given that Dotbird is also PQ ready, Dotbird then send the standard TLS data plus the PQ extended data back to Alice. With all this data, then they can have a link that is safe against a quantum computer. Now, this is the ideal case where both parties are PQ ready, but unfortunately, we live in non-ideal world. So you have cases like this. Here you have Dilbert, who is not PQ ready, and he wants to talk to the super smart server, Dotbird, which we know is PQ ready. So Dilbert started by sending his TLS data, the standard one. But at that point, Dogbert realized that actually he is not PQ ready. Now, it's up to Dogbert to decide whether or not he wants the connection to continue. So this kind of situation is quite common during the PQ transition period. We would expect that not all devices will be migrated in one go. So here we assume that Dogbert has the policy to allow the communication to continue. So in this case, Dogbert will fall back to standard TLS to allow a link to be established between them, but the link is not quantum safe. There's another example here. You've got Alice, which we know is quantum ready, and she wants to talk to the boss, who unfortunately in this case is not quantum ready. But Alice doesn't know about that. So Alice does the same thing, send her standard data to the boss, and followed by the extended data, PQ data, to the boss. Obviously, the boss will understand the standard data, but he will not understand the PQ data. So he just ignored it. And then he sent back the standard data to Alice. Here, Alice at this point will have to make a decision whether or not she wants to continue talking to the boss or drop the connections. It is a policy that she has, so it's up to her what she wants to do with it. If she decided to continue, then she will fall back to the standard TLS 1.3 that is not quantum safe, but they will be able to talk. Now, the last two examples here shows that if we baked in backward compatibility to our hybrid protocol extension, it will allow us to be interoperable with any of these non-migrated devices. And therefore, this will simplify PQ migration process. I don't think it is possible to do the PQ migration in a big bang, right? So things got to be done in phases. Perhaps we start with more critical devices first, and then roll that out to larger pool devices, and so on and so forth. Now, it is not practical, in my opinion, to do this PQ migration in a big bang. JSON Web Token is a stateless and scalable authentication mechanism that is used in many modern applications. In Nomidio, we rely on this web token for our identity proof and the associated claims. We also use this for our inter-microservice communications and authentications. As per the current standard, this token largely rely on RSA and elliptic curve. So we decided to take this opportunity also to hybridize the web token, both for signatures and the encrypted token. But you may then ask, why do we do this? Most of the time, this token will be sent over TLS anyway, and you have a mechanism to hybridize TLS. Well, that's the point. Security is all about layering. We cannot just trust a single layer being secure. In this particular example, what if the token is sent over TLS link that is not quantum safe? The case of Alice and the boss, and Dilbert with the server Dogbert. So for us, in order to minimize this risk, it's worth the effort. Okay, so we have talked about transitioning TLS, VPN, JSON Web Token to post-quantum cryptography. But as with many applications out there, the migration doesn't just stop here. When you compile a catalog of all crypto that is used in your system and application, you will most likely find that there will be cases of application-specific cryptos. With Nomidio Identity Cloud, there's no exceptions. We have a number of microservices, and some of them implement crypto-specific functionality. Just to give you an example here, we have our quorum approval microservice, which we use to assist in identity recovery in case a user has lost access to their account. This module is implemented using threshold cryptography, which will need to be migrated to post-quantum. Okay, so I hope you find this presentation useful. There may be a lot to take in, but there are key takeaways that I want you to remember. The first one is post-quantum cryptography migration is a complex and time-consuming process. You should plan early on this, in particular if you want to keep your data confidential for a long time. Secondly, hybrid approach is the way forward. You can already start experimenting or build some POCs with hybridized protocols. So thank you for your attention.